Hi guys, so we are coming back to take a look at carboxylic acid. Let's start with the MCQ. Okay, so here we have a diagram that shows a reaction scheme for formation of compound Z. Compound Z now, it looks very daunting, right? It looks very complicated, but let me break it down for you. Actually, it is just a 3D representation 3D representation of cyclohexane. Okay, so cyclohexane in your normal 2D representation looks something like this. Okay, but in 3D boat configuration, right, it looks like this. Okay, so this is your boat configuration. Okay, why do we need to use this boat configuration, right? Because this shows the 3D the 3D feature of it, because as you know, each of the carbon is supposed to have a tetrahedral shape. Okay, so this boat configuration will allow the carbons, right, to display their so-called 3D tetrahedral shape, which you can't really show if you are using this flat structure. Okay, tetrahedral is not flat. Okay, so we need to use a boat configuration to show the 3D features. Okay, so having said that, let me just raise this away. So once we understood that, right, we know that this part here, the highlighted part, is your cyclohexane. Okay, and then how about the part that is on top? This is actually a ring structure between position 1 and position 3. Okay, 1, 2, 3 on your cyclohexane. Okay, so in order to solve this question, right, we got to look at the options. Okay, this is your amide linkage, okay, which is formed between substituent on the first and on the third carbon. Okay, so if you look at the option A and B, right, you have substituent on the first and the fourth carbon, which makes it wrong to solve this question. So we need to look for first and third, which is what option C and D gave to us, first and third. And then the next thing you want to look at, right, actually you want to look at this part here, the green highlighted part. You realize that on the carbonyl side, right, you actually have two carbon, okay, 1 and 2. All right, which means that there should be 2 carbons on the carbonyl side. Okay, both option C and D will have. Then the last difference, right, is that you notice option C has bromo, option D has the hydroxy group. Okay, so if you look at step number 1, right, step number 1, you are doing nucleophilic substitution using ammonia. So ammonia will need to substitute a halogenal alkane because ammonia cannot substitute a hydroxy group. Okay, that's not possible in the H2 syllabus. Okay, so option D is out. Therefore, our answer is option C.